true projects. In this video, we are going to explain about the project that is VGG16, VGG16 with random forest, Resnet50 with support vector machine, and EfficientNetB0 with XGBoost, enhancing bone fracture classification in X-ray using deep learning models. So before getting into the execution, first let us understand what is this project about. So bone fractures, they happen very frequently around the world. They can occur due to accidents like falling, car crashes, or sport injuries. Sometimes they also happen because of persons of bone weakness, which can be caused by conditions like osteoporosis. When someone has fracture, it is really important to correctly identify the type of fracture so that they can get the right treatment and recover properly. So traditionally, doctors or radiologists look at X-ray images to figure out the type of fracture. However, this process can take a lot of time and there is chance of mistakes because it relies on human judgment. So even experienced doctors can sometimes misinterpret images or take longer to make a decision. And recently, machine learning models and deep learning models are being using. So machine learning models and deep learning models have become very useful in helping doctors diagnosing bone fractures more accurately and quickly. These technologies can analyze X-ray images and detect fractures in ways that are faster and often more precise than the traditional models. However, with these advances, there is still a lot we don't fully understand about which specific models or combinations of the models works best for fractions, that is fracture classification. Many of existing systems don't perform consistently across all types of fractures or different set of X-ray images. This means that while some models work well in certain situations, they may fall in others, which makes them less reliable in real-world clinical practice. So because of this, challenges, it is important to carefully study and compare different machine learning and deep learning approaches to find the one that are most accurate, consistent, and practicable for diagnosing bone fractures. So to overcome with all such issues, this project it proposes an automated framework that leverages transfer learning models along with the machine learning models. So here it aims to create an automated tool that can accurately identify and classify bone fractures from X-ray images. So instead of relying solely on doctors to examine the images, the system uses advanced computer models to do the analysis. So here it makes use of several transfer learning models, which means it takes pre-trained deep learning models like VGG16, Resnet50, and EfficientNet B0. So here we will be taking all these transfer learning models. Then comes ensemble models. So here, to make the predictions even more reliable, the system also combines these deep learning models with ensemble learning models, such as random forest, support vector machine, and XGBoost. These ensemble methods helps to improve accuracy by considering multiple models together rather than depending on the single model. In simple terms, the system blends powerful image recognition models with smart decision making algorithms to create a reliable and automated way to detect and classify. So, here the first step is data pre-processing. So, at the stage where the X-ray images are prepared for analysis, this involves cleaning the images to remove an unnecessary noise, that is, any unnecessary noise data, resizing them so they are all on the same size, and normalizing them so the pixel values are consistent. Next, we will be doing feature extraction. So here we use pre-trained CNN models. These models are able to recognize important patterns and details in images that help to distinguish between different types of fractures. So finally, these extracted features are then fed into ensemble classifiers, which combine the predictions of multiple models. This improves the system's ability to make accurate predictions and ensure that it performs well across different types of fractures and variety of X-ray images. And these models are evaluated using accuracy, precision, recall, and FN scores. So all these models are evaluated by using these metrics. So by combining deep learning models with the ensemble models, the system can overcome the weakness of using a single model alone. This helps to reduce mistakes in classification and makes the system more reliable. Overall, it provides a strong decision support tool that assists radiologists and also healthcare professionals in identifying fractures more accurately and efficiently. Moving on to extensions. So to further improve the performance of this project, here we are incorporating several models. So first we are incorporating exception model. So this exception model has been added to the work alongside with the other ensemble setup. which helps to improve the system's ability to analyze X-ray images more accurately. On top of that, here we are also we are adding a detection module by using YOLO models. So this module can automatically find and locate the abnormal areas like fractures in the X-ray images without needing manual guidance. Together, these additions make the system better at both identifying and understanding fracture images. And to make the system easier to understand, we are using explainable AI techniques. Specifically, we have applied GradCam, which creates heat maps on the X-ray images. These heat maps show which parts of the image the model is focusing on when making its predictions. In other words, it visually highlights the areas that are most important for the model's decision, helping doctors and users see why the system predicted a certain fracture type. And here, we have developed a simple web interface by using Flask, which also includes user login authentication for security. This interface lets user upload X-ray images and get predictions from the trained models directly. By adding this web application, the system becomes not only more accurate and also easier to interpret, but also more practicable and also access for the users. Moving on to the implementation. To implement this project, here we have followed the steps which are mentioned in the flow of work. So let's understand how we have implemented this project. First, we have imported all the necessary Python libraries and packages that are required for image processing, model training, evaluation, and building web application. Then comes data preparation. So here we have collected X-ray images for bone fracture classification. For classification, we use images with their corresponding class labels. And for YOLO, we create bounding box annotations in YOLO format, that is .txt format, to indicate where fractures are located. Then we split the data into training and testing sets. Then comes visualization part. So here at this stage, we create bar graphs to show the distribution of different fracture classes in the data set. And sample labeled images are displayed to check the annotations that are correct and consistent. Then comes pre-processing. So here at this stage, we resize, normalize, and augment the images to ensure consistency and improve the model's ability to generalize. Then comes image data augmentation. So here we apply image augmentation techniques like rotation, flipping, or brightness adjustment. Then we have used several transfer learning models to extract important features from the images. Then we have created data.yml file for the YOLO that contains image paths and class names. Then we have maintained two separate data sets, one for the classification and one for the YOLO. And here we have developed models for classification and for detection also. So for classification, we will be combining transfer learning models with the machine learning models. And then comes model evaluation, where we have evaluated all the models, classification models using accuracy, precision, recall, and FN score, and evaluated detection models using these metrics. And we saved best performing model for the future use. And coming to this inference pipeline. So in inference pipeline, we input an X-ray image into the system, and output includes a bounding box on the fracture and a predicted fracture type. Coming to the front end, so users, they upload images in the front end. So actually, front end has been developed by using Flask framework, where users will be able to provide the input images that will be pre-processed. It will be fed to the saved machine learning model, that is saved deep learning model, and that will be giving the prediction. And also, if you want detection, YOLO models will be giving the detection. Moving on to the algorithms used. So these are the transfer learning models that are used in this project, and these are the ensemble models used in this project. So transfer learning model is combined with the VGG16, support vector machine is combined with Resnet50, XGBoost with the EfficientNetB0, and ensemble of exception with the Resnet50, which is an exception extension model. And for detection, we have used these models. And to implement this project, we have followed the steps. We need few requirements, which are hardware and software. In hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And software requirements needed are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute it. To execute, open the code folder that contains source code files. So these are the source code files of this project. Let's understand each of them. So in this folder, we have the bone break images, which are used for classification. So here we have different categories of bone fractures. So here total we have 10 different bone fractures. So here we have evolution fracture. So here we have two subfolders, train and test. So let's open train folder. So these are the images of evolution get back. And here we have images of bone fracture of comminuted, that is comminuted fracture. And here we have fracture dislocation. So these are the images where dislocation of the bone. And here we have green stick fracture. So here we have images of green stick fracture. Accordingly, we have images of all the respective fractures. Now get back. And the data set which is in this folder is used to train the classification models. And here we have model folder in which we have algorithm information that will be loaded into the project code during runtime of the application. And here we have static folder in which we have CSS, JavaScript and Bootstrap files which are important for the project's visual appeal. And here we have templates folder in which we have HTML pages that are used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have test cases folder. In this, we have test cases that we will be using in the front end. And in this folder, we have the dataset that is used for YOLO models. So here we have 3 subfolders. Let's open train folder. And here we have 2 subfolders. So let's open images folder. So here we have all the images, all the clubbed fracture images, all the different 10 types of fractures that are clubbed here. So these images are used to train the YOLO models. And object locations of those fractures are in this label folder, which are in TXT format. So these contain object locations for those images. So each label file, it contains the object locations, that is the fracture locations of the corresponding images of these images. Now get back. So this folder is used to train the YOLO models. And this is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have model file, and here we have 2 Jupyter Notebook files, 3 Jupyter Notebook files, which contain a combination of code, graphs, and outputs all in one place. And it allows users to write and execute code in individual cells, making it a popular choice for the data science. So here in this Jupyter Notebook file, we will be loading this data set and we will be training the models for classification. And for in this Jupyter Notebook file, we will be loading images which are in this folder and training the YOLO models. And this is the database file which stores the user information. So this is all about the code folder. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. So I'm copying it. Now open Anaconda prompt. So it's open. Give the command cd, give the space, paste the copied path, click on enter. So here you can observe current directory is changed to the code folders path. Now compile app.py file. So give the command python space app.py and click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flash Framework will host the application locally at the default address, which is the localhost and the port, unless configured differently. So just wait for a while. File is being compiled. So this is the address where application has been hosted. Let's copy it and paste it in any web browser. So I've copied it. I prefer Google Chrome, so I will paste it in that. Paste the link here. Now click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flash Framework. So this is the web page of this project. And now let's start doing execution. So click on sign up and create an account if you have not created. I have already created, so I will directly sign in. Click on sign in here. Provide your username and the password. Click on sign in. We have signed in successfully and redirected to classification page of this project. So here we will be doing 2 kinds of predictions. One is classification and the other one is detection. So first let's do classification. So click on classification. By default, you will be redirected to classification page. So let's click on choose file to upload images. So click on it. So now open test cases folder. As we're doing classification, let's open classification. So we can upload images from any of these folders. So let's start from the last. So let's open this one. Click on classify fracture. So this given image, it will be pre-processed at the backend. It will be fed it to the trained model, and then trained model will be giving us the prediction. So here we got the prediction. This is the image that we have given for analysis, and this is the AI analysis result, which has been created by the GradCam image. And here we have prediction to be spiral fracture with the confidence of 100%. So this is the confidence score with the 100%. And here you can see GradCam image. So this GradCam image, it highlights the regions of MRI that the model considers most important for its prediction. So here you can see red and yellow region, right? So this is the area where it shows the high influence, indicating whether the model focused on classifying that to be a spiral fracture. So it is focusing on this area considering the spiral fracture. Now let's try analyzing another image. So click on choose file, get back. Let's try with this one. Let's open it and click on classify the fracture. And here we have the prediction. This is the image we have given, and here we have AI analysis result. So this is the area where it is focusing on to predict the image to be pathological fracture with the 100% confidence score. So person with this X-ray is having the pathological fracture. Let's try using another image. Click on choose file and now get back. Open this one. Let's upload this one. So here we got the image analysis. This is the original X-ray we have uploaded, and here is the area where it is focusing on. And here we have prediction to be oblique fracture with the 100% confidence score. Let's try with one more. Get back. Let's try with this image and click on classify fracture. So here, this is the image original X-ray, and here is the area where it is focusing on. And here we have prediction to be longitudinal fracture with the confidence of 99.99%. Let's try with the other one. So click on choose file. Now let's give images from this folder. Let's try with this one. And here we got the prediction. So this is the area where it is focusing on, and this is the original X-ray image that we have given. And here you can see a pathological fracture has been classified with the confidence of 99.43%. Now let's try with the other image. So get back. We have tried with this one, right? So now let's try with this one. Let's try with this one. And here we got the prediction. This is the area where, that means this is the area where it is focusing on to predict it. And here it is predicting it is a hairline fracture with the confidence of 99.98 confidence level. Now let's try using the other image. Click on choose file, get back. Let's try with this image. And here we got the prediction. This is the image we have uploaded, and here is the area. So here you can observe this is the area where it is highlighting. So this is the area in this original image. And here you can see we have green stick fracture with the confidence of 99.89, which has been classified. And this is the confidence level indicator. This line represents the confidence level indicator. Click on it. Let's try with few more images. Get back. Let's try the dislocation. Select it and classify it. And here you can see this is the area where. So here you can see red and yellow line, right? So here is the region where it is focusing on to predict it to be it's a fracture dislocation with the 100% confidence score. Now let's try with two more images. Click on choose file, get back, open it, and let's try with this one. Click on classify fracture. So here we have, this is the image, GradCam image, and here we got the prediction that it is comminuted fracture with the confidence of 100%. You can see, right? Now let's try with the last image for classification task. Get back, open the first folder, select image and classify it. So here we got the prediction. This is the original image, and here is the area where it is focusing on. So here you can see red and yellow area, right? This is the area in the original image. And here you can see a correct classification, that is avulsion fracture has been predicted with the confidence of 99.9%. Now let's try to do detection. So click on try detection mode and click on choose file to upload the images. So get back, Open detection folder. You can upload any image. So let's upload this one. Click on detect fracture. And here you can see a green stick fracture has been detected and a bounding box is drawn around it with the pink color bounding box with the 100% confidence score and labeling it as green stick. So let's try with another X-ray image. So click on detect another X-ray. Click on choose file. Let's try uploading this one. Click on detect fractures. So here you can see a longitudinal fracture has been detected with the green color bounding box with the 100% confidence score. Confidence score is nothing but how accurate the detection is in detecting this particular class, that is longitudinal class. So it is 100% accurate in detecting this longitudinal class. Let's try detecting another image. Click on detect another X-ray and click on choose file. Let's try with this one. And here you can see a dislocation has been detected with the 100% confidence score. Let's try with other one. Click on choose file. And now let's try with this one and click on detect fractures. So here also you can see dislocation has been detected. Click on detect another image. Now let's try with this one. And here also we can see dislocation has been detected. Let's try with some more. So let's select this one. So here pathological fracture has been detected with the 100% confidence score. Let's try using the last image. So click on choose file. Let us upload this one and click on detect fractures. So here green stick fracture has been detected and a pink color bounding box is drawn around it. So if you want to switch to classification mode, you can click on this blue color key, that is try classification mode. So we have completed classification as well as detection, right? So let's click on back to home. And let's see the graphs of classification. So click on graphs and under graphs, click on classification. So here we have the graphs. First graph is the confusion matrix graph, and this is the accuracy score comparison graph. And here we have precision score comparison graph. Here we have recall score. Here we have FN score. And here we have line plot of all the metrics. And here we have stacked bar graph of accuracy with FN score. And here we have stacked bar graph of precision with recall. And now let's check the graphs of detection. So click on detection. So here we have a YOLO precision score graph. Here we have YOLO recall score graph. And here we have mean average precision score graph. So now click on sign out. So this system, it shows how technology can help doctors making faster and more accurate decisions when diagnosing bone fractures. By analyzing X-ray images automatically, it supports healthcare professionals and ultimately help patients receive the right treatment sooner. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.